aptitude, reasoning and other topics that are asked in your banking exams, computer awareness is one thing that they will test you on. So your aptitude and reasoning are regularly used things in your banking life, but computers has also become a regular thing right now, right? So looking at that, the kind of questions that are asked, they start from the basics of computers, and then based on today's advancements that are happening, they'll ask some questions in some areas to the depth of it, to the core. So for example, MS Office. MS Office is one such integration that is done with your banking software, like MS Word, Excel, Outlook. All these things are softwares that are available in MS Office package, right? So these softwares from this package are integrated with the banking software. So you need to send a report. What they do, they collect the data in their software and then they dump it into that Excel sheet and then send it across. They need to give a presentation. They'll use this data, create a PPT and then send it, right? So there are a lot of integrations that happen. Outlook, so any mail that has to go, they directly click some button or shortcut in the software and it will automatically come and land you into your Microsoft Outlook. And from there you will send the mail probably to the customer or to the back-end office or whoever it is. So all these integrations that happen, so the questions that they ask regarding MS Office or Windows operating system and all these things will be to a level depth, not at the high level. But when it comes to the basics of computers and all, they'll ask you some questions at high level, like what is RAM, what is ROM, and what are the internal storage devices called, external storage devices. All these things they'll discuss at a high level. These things they'll go in depth. One of them is Microsoft Office, and then the other one is Windows, the regular operating system that is used. And then next thing that is majorly asked is about network. So how the network happens, how the OSA layer, and then what are the different kinds of topologies in networking. All these questions will be coming from networking. And then another major topic that questions come from is memory management. So in memory management, the thing is how the internal memory is managed between the CPU and the temporary memory. So how it is managed, how the processing happens, and how is the memory helping the control unit to do the processing. All these things are discussed in memory management, and there will be in-depth questions in these areas. So when I say these areas are for sure that you have to go in-depth or understand in-depth, okay? But there are few other things which go at basic level. So today we will start with the basic level information. So we will cover all these things in that basic information at a high level, and in the further classes we will get to know details of each of these things. Okay, so when I am starting, we will start with the zero level fundamental. What is a computer? Now when I say what is a computer, I am not asking about what it does. Everyone knows what a computer does, right? It basically handles our calculations, what we have to do. In fact, simple calculations anyway we do, but if there are any complex calculations, that is what we build the computer for. Apart from calculations, there are a lot of other applications that it handles right now, okay, after the advancements of their computers. But what I want to start with is, what is the composition of a computer? What do you call, what are the different things that you see when you say this is a computer? So one is CPU, right? What is the other things? Tell me few things. Monitor? Mouse? Keyboard. What more?
UPS.
Okay, UPS. Speakers?
Yeah.
Right?
Yes.
And then a printer or a scanner?
Headset.
Yeah, speaker and headphones, like, so scanner, printer, and there could be a lot of other things which can be put onto the computer, right? Now, when I say what is a computer, do I need a printer or a scanner for a computer to run?
No.
Not required, right? Same thing, speakers, only if you need to listen to something you need speakers, otherwise it is not required. UPS is a power backup system, right? Keyboard. Do you need a keyboard to run a computer?
Yes.
If there is nothing that you need to do an input, why do you need a computer? If you get to go to a gaming zone, there are a lot of gaming zones in malls, right? So if you go to a gaming zone, those are also computers that are running the game.
Yeah.
Do you see a keyboard there? It's just a joystick, right? If you are playing a car game, you'll have steering and all those pedals and everything. There is no keyboard, but still you are able to operate the computer there. But just with the joystick.
That itself, it's an input for that, like whatever we are in.
But that is not a keyboard, right?
Yeah, it's not a keyboard.
It's a joystick. Let us say there is another thing called joystick. Okay. So this kind of input is available, but this kind of input is not available because it is not required there.
Yeah.
Right? So when a joystick is not required, we don't use joystick. When a keyboard is not required and a joystick is required, we use joystick. So this is not mandatory. That's what I am saying. Wherever it is not required, that is not mandatory to say that a computer is there. Mouse, it is same as any other input device. Joystick and mouse are almost the same, right? Mouse is a very basic level of operation. Joystick has an advanced level of operations, right? So if we need, we connect it. If we don't need, we don't connect it. Now again, monitor. Do we need monitor always for a computer?
Always.
Only when you need to see something, you need a monitor. If you don't need to see, why is a monitor required?
Without seeing, how will do the things?
See, there are a few areas where you just play, right? For example, a computer is connected to a music system. Then automatically the music plays. You don't see the monitor there. You just listen to the music, right? Probably when you go to theaters, in the waiting halls and all, you listen to a lot of music that is played from a computer. In fact, you have gadgets like Apple has released a small gadget which will play music. Do you see a display there? There is no display in that small MP3 player. So you don't have a display there. You just have to go next to reach to the song that you want to listen, and then you listen. So there is no monitor there. So monitor is required only when there is something that you need to see. If there is nothing that you need to see, monitor is not really required. Am I right? So even this is not a mandatory part of a computer. So what is that it is mandatory? If this is not there, there is no computer. Am I right? The processing unit is the part that has all of the things, right? You have the microprocessor and everything put in this CPU. So that cabinet, that CPU is what is required to say the computer is there. But to use it, you may need some of these or one of these at least. Okay, so all these things that are there on the computer, we call them as what in general term, we call them accessories, or in other terms, peripherals. Okay, so these things can be attached and detached as per the necessity. That is what the meaning of this is, right? Now we know that this is the primary thing for a computer to run. Now when you know that, let us look a little bit more into what is a CPU, what are the, how is it constituted, what happens inside that. Now this part, whatever we are going to see here, is one of the major parts where I said memory management happens, right? So this memory management, now what we see here or understand here is at an overview level. Now later in the next class, when we discuss only about memory management, we will dig deep into this CPU part. Okay. Now there is something called that gives an input, whichever it could be, and then there is something called an output. Okay. Input goes and output comes. So this is the CPU. In this CPU, what all will be there? There are two major parts. One is the memory. So this is, again, what is this memory? This is not your hard disk, not the permanent storage. This is only about your temporary storage of the memory. Okay? We call it as cache or RAM or whatever it is, but it is a temporary storage location. Now here you have the major part, which is called the control unit. The control unit. And then you have the other part which is arithmetic and logical unit. What is arithmetic and logical? Arithmetic means all your addition, subtraction, multiplication, division, square root, all these things are part of arithmetic operations. Logical operations, and, or, less than, greater than. Okay, so all these operations will come under this arithmetic and logic unit. Now we'll discuss about this, but let us see how the processing happens inside this. Now there is an input. Every input that goes into this control unit is known as an instruction. Everything that we send to a computer is known as instruction. Okay. Now first thing is, before understanding what happens here, what does a computer understand? What language does a computer understand?
Binary digit.
Binary language. So what is binary? It is 0 or 1. Except these two things, a computer cannot understand anything else. So how is it that we are typing in English and it is responding to us in English? We are typing in fact, Google or other things, they have come up in our own local language also, right? So we give input in our language, whichever language we want, and the output also comes in the same language, right? So there is something happening behind the scenes which is giving the output in the way that we want, not in the way computer understands or in the way the computer uses, right? So I'll tell you what happens and how has it evolved. We'll understand while we are going in the next level. But for now, just understand this part or remember this part, that computer understands only binary language. Now everything that comes inside is an instruction. Now I'll start with a very simple instruction. But before going that, let us say I am running a program on the computer, and the computer is the software name is payroll generation software. What is payroll generation? It will generate the pay slips and calculate the salaries that need to be given to the employees based on their attendance. All these calculations will be there. So you can understand it in overview that it is a payroll system. Now I am running this application on the computer. So it is naturally running on with the help of the control unit. Control unit is actually running the program. Now I give an input. That basic HRA, travel allowance. These three I have given the input. Some three numbers, some 500 or 600 and some 400, some numbers just for the sake of taking. Now when I say this, I want the salary. What is the total salary? Right? What is it doing? It is simple arithmetic operation, adding up of all these things, right? Now when I am adding up of all these things, payroll system is the actual application that is running. So where should the addition happen? It should be written as a subroutine in the program, right? So it should be a part of the program, a subroutine written in the program. But what happens is the control unit actually, when it takes these inputs, what is the first step that it does? It goes to the memory unit. It goes to the memory unit, creates slot for each of the points and inserts the information there temporarily. Okay? From there again it takes the information back and comes to the payroll system. Now here in the payroll system, because it is basic arithmetic operation, the definitions of how to add two numbers or how to subtract or how to multiply, those things are not written in any of these applications. It is only written that addition should happen, right? So the moment it comes into the payroll system and checks for the subroutine, it is written as addition should happen. So what it does, it takes the addition point and then says, because that belongs to an arithmetic or logical unit, it goes back and executes it in this arithmetic unit. Okay, the reference of this is a library file. Arithmetic and logic unit is available as a library file. That library file is referred in this payroll system. Are you getting it? Understanding it? So instead of writing how to add two numbers, how to multiply two numbers, that program is already written. A common program is already written and that is there in this unit. So instead of me again defining how to add and how to multiply, what I do, I refer to all this ALU in my system, in my application. So the control unit directly goes to the ALU, does the calculation, comes back, again goes to memory, updates the memory with the new values, whatever are there, and then through the output, it will display you what is the result. If there is anything else that it is doing apart from arithmetic and logical operations, it will execute that operation or that instruction in the payroll application. Right? So this is how the overall thing happens in the CPU. How it interacts with the memory and ALU is what we have seen now. This is at a basic level. But these two things operate very efficiently and with a lot of process in hand, so that all these things will happen just like that. You don't need to wait to send all these things and wait for 1 hour or 2 hours to get the result, right? It comes just in a millisecond. So how that it is handled within that millisecond, running all this program and doing all these steps and all, we'll learn when we go into memory management in detail in the other class. But for today, let us look at it at an overview level. Okay? Now, let us get to the next point. We'll travel a little bit into the history now. Now in this history, I'll discuss about how it all started. Let us look at the different, evolution of computers and how it happened, what are the different things that happened. So there we learn about these things also. Now first thing is, who is the father of the computer? Charles Babbage. Right. Now, is it that before Babbage there was no computer? Yeah. Before Charles Babbage has invented it and said that this is a computer, there was no computer. But there are mechanical tools, different tools built even before him. Right? The first tool, as far as we know, that was built on mechanism was a tool that observed the astronomical objects that are moving in the space. This was invented in Greece for the first time. So later on, Charles Babbage came, and a lot of other calculation tools happened. A tool that can solve the calculus problems, number system problems. There are a lot of tools that were invented. All these tools were put together, and then Charles Babbage created something called a computer. So that is why he became the father of the computer. Okay. Now, once the computer was invented, the first generation, if we look at it, the first generation computers, the technology used to build those computers was vacuum tube technologies, right? So why vacuum tube? So that there is no media to disturb your electricity and also the data, right? Now, it is the best way to propagate data and electricity. So that is how the first generation computers evolved. Using vacuum tubes and all, the computers that they were made, well, it was an invention at that time, so probably nobody had any difficulty to use it, and it was not used in every place. It's like that was an invention still under the making, right? So it was used with vacuum tubes, and because it was built with vacuum tubes, it had a huge size. Okay, and then if you have observed what they call these radios, olden days radios, they used to be very huge in size, almost like this split AC box, right? That used to be the size of the radio, because the technology that was used was similar to this vacuum tubes and all. Okay, later on, what happened? First thing is size. It was huge in size, and then slow in processing. Slow in the sense, when we compare it with today, yes, it was slow. But when you look at it from the day it was invented, then it was an invention. So there is nothing called slow or fast. At that time it was up to the mark. But if you compare it with today, then it is called slow. Okay? And then it was consuming lot of power, consuming lot of electricity, and then generating lot of heat. There used to be kind of huge fans to cool the system. Even today we have a fan, but very small.
Yeah.
Right? So this was the things at that time. Later, after this, when the second generation has evolved, or the research happened and the evolution progressed, in the second generation, they came with something called transistors. these transistors are like the same kind of technology reinvented, but in a very small size. Okay, so the whole computer with the big things and fitting into a room kind of a thing was compressed and put into a small thing. Okay, so after transistors came, size was something that was solved. The problem of size got solved, and then speed is like still slow because there was no invention towards the increasing the speed of the computer. Then came consumption. Not a big change in that too. Heat, yeah, a little bit of add-on happened there. Not generating too much of heat. But again, if you compare it with today's kind of a situation, then this transistor as is using the technology is good. But to process 1 MB data. 1 MB is what? Today if you take a selfie, it will be more than 1 MB, right? So maybe during those days when it was invented, 1 MB is a huge data. So to process 1 MB of data, you need 8 lakh transistors. So what happened again? Now a transistor is a small thing, right? Maybe this small. But when you say 8 lakhs of it, again piles up to a huge size, right? So if we had continued with the same transistors today, again the computer could be of huge size. You can't even imagine the size because just for 1 MB you need 8 lakh transistors that were invented at that time. Okay, now later on when this passed out and the third generation happened, integrated circuits or ICs, you used to call them ICs, integrated circuits. This was the next generation computer. Okay. Transistors and these integrated circuits are still used in different applications. Okay, in different ways, where there is not lot of memory that is required or manipulation that is required, but still transistors can be used to transfer the content or used for temporary storage and all these things. These things are still in use in different applications. But for computers, these could not withstand because here it is about the size, and here the integrated circuits they could not handle the circuit. Okay, they were collapsing. Okay, so these two happened, but they could not sustain in the market for a long time. And then the revolution happened. The fourth generation came, and the revolution happened. The revolution name is microprocessor. Even today, we are using the same microprocessor. Advancements are different, but by the invention side, still we are in the microprocessor age. Okay, this microprocessor was first done or created by Intel. Even today they are the ones who do it, but there are other companies who also build. But however, Intel started this microprocessor. This all different technologies, enhanced and made into a very small kind of a chip. So the size of this. And then that chip is used in our computers, laptops, every gadget. So the chip has now reduced furthermore and has become an operating system or your operating chip in your mobiles also. Right? Mobiles, if today's applications if you look at, even your refrigerators, washing machines, household electronic appliances that you use in home, and then your gadgets, electronic gadgets, all your mobiles, iPads, tablets, PCs, everything, and then even your automobiles. Now the latest sporting bikes and then cars, all these things run on those chips. Okay, however, the chip that is used is same, but the composition is different, right? The chip that is used in a computer is much more bigger in the sense not about the size, it is about the capacity to handle things. So the chip that is put in a computer can do everything and that is required. But when you compare it with a washing machine or a car, it can handle only few things. Like in the washing machine, you don't need something to do calculations, right? It is just you select the kind of operation that needs to be done, how the clothes need to be washed, and they wash it. So there are limited operations. To do limited operations, you don't need the complete processor. You need a part of it. So that is, divided, and only that part is maintained in the washing machine and other appliances wherever it is required. We will discuss this in detail in the memory management again, because that is where I discuss about operating systems also.